Hello, students. Hope you all are doing well after the week we had with one video lesson and got some good time to get caught up on our earth space science work. Welcome, as you guys know, with this new week. We have 1 month left of online learning. And if we look here at the EDSB on the screen here, we do have our latest assignment, which is the Unit 8 Vocab. So make sure to complete and work on that. That is going to be due on Sunday at 11 p.m. And we will have our next weekly unit quiz on Friday, being posted Friday morning more than likely, which should be within a timely manner completed that weekend, which should be, I'd say, Sunday night as well. This week will be a little different. We had one video lesson last week. Instead of 4, we'll just have 3 this week, and then maybe 4 for the next 2 weeks. And I'm still kind of trying to figure out what we will do. Maybe that exam week a little different than the other usual weeks. But let's go ahead and go back to our presentation here. Just wanted to show you again our first word's galaxy. We get universe, redshift, blue shift, velocity, all that. Again, you see just 15 words or 20 points due on Sunday night, which some of you guys are already completing. So great job. But let's go to our presentation here just so we get an idea of what we need to know today. Kind of get some old things we need to discuss, some new things, right? Oh, 1 second, guys. All right, back to our latest Go Blue. And waiting for the screen to pop up here. Here we are. Okay, so on page 8, number 1, what does cosmic background radiation provide evidence for and why? 2, what type of waves are CBR, that is short for cosmic background radiation? And 3, what device first discovered CBR and what device is used to read it today? Some updates include, again, grades still being updated fully, messages getting back on those, and the Unit 8 Vocab and Unit Quiz number 5 are due on Sunday this week. Take a moment to pause, think about those answers from the previous week, from last week's lesson on Thursday or Friday, I believe. And we look here, it is evidence for the Big Bang Theory, the idea that the universe started at a single high temperature point and expanded over time. And then we have evidence of that because that radiation has a similar temperature to the radiation that supposedly came from the Big Bang, right? So pretty interesting links there that we're making, some evidence. There is evidence of the Big Bang with that radiation floating all around space when you go outside of the spacecraft, right? 2, what type of waves is that radiation? They are known as microwaves. Again, they are called microwaves. And 3, the original antenna is called the Bell Labs antenna. And the newest antenna that we use today to read these radiation waves, we call WMAP. I think it's the Wilkinson something, but we're going to check that out today. That is brand new material that we didn't have time to cover last time. So that concludes our Go Blue. Here is our table of contents, pages 8 and 9. We're going to start a little bit of this today, which is dark matter and dark energy. Again, just when you look up into space, what is with all of the darkness and all the dark stuff in space? It's got to be something, right? We can see it. What is it? Why is it that way, right? Get to that a little bit later. Let's go to our first practice question that if we had cards, we would use these for this. Most galaxies in the universe are in blue shift because the universe is expanding. Again, if it's blue, is it going away or going towards? Is this A, true, or B, false? The answer is B, false. Again, left and red, they're going away. Right, blue, feeling blue, go to you. So again, most universe is expanding because of the Big Bang, and that would mean most of it's in redshift. Hence why most stars are like kind of yellow, orangish in color, right? Moving on, back to finishing cosmic background radiation on page 7. Again, just to kind of give you guys, here is the Bell Labs antenna, some background on the Big Bang. Well, actually, we'll get to that in a little bit. We'll get to that first video here. I got 2 videos today. So if I look here, guys, again, we need to make sure we write what's in yellow, okay? Mapping the radiation, right? I think that's what it says. I think I got a little tab here. It's in the way. Yep, mapping radiation, okay? So observations show that CBR matches, as we just discussed in our Go Blue a little bit, it matches the leftover hot radiation from the Big Bang, from its expansion, right? So space isn't just a super cold, nothingness. It's got things that aren't visible to the eye that we can see through satellites. That's the radiation, right? The fact that if you were in a spacesuit, you took one of the sleeves off of it and you exposed your skin to space, that radiation would burn your arm to a crisp, even despite it being cold, right? The Earth's atmosphere blocks most of the CBR, so it's best observed from balloons or satellites. By the way, guys, we're still back on page 7 for this stuff, so this will be on page 7. And then we use the Wilkinson map anisotropy probe, that's what we just talked about, right? WMAP, to map the radiation today. So again, guys, just so we're all clear, again, WMAP, here's a little visual of that there. And this is on page 7. Again, we're still back on CBR on page 7. If you need more room, make a page 7B or continue it on page 8, however you see fit. Okay, what this first bullet here, again, how we knew the expansion accelerated. This first bullet point here, no need to necessarily write that, but just write what's in yellow. We are able to now pinpoint the age of the universe, which is almost 14 billion years old, approximately speaking. Again, we're using math and physics to figure this out. Is science always 100% correct? No, but they try to make adjustments and make it better over time. We also recently discovered that the expansion of the universe is now accelerating. It's speeding up. So space is infinitely speeding up in acceleration. So very fascinating, incredible things, despite how small we are in comparison to know there. So that is the 2 out of the 3 things we're going to continue with today for our cosmic background radiation. But that's going to go against, this is kind of the visual of that expansion, right? We can see all these galaxies. We're in one. We know that would be the Milky Way galaxy, and more space, more and more area over time. Pretty incredible, astounding things to even think about or put your mind around, right? So let's go ahead and take a look at my first video clip of the day, just to get, again, I posted these to Edsby, but just to get kind of an idea in regards to expansion. Again, it's on you guys to watch all this on your own.
Because light takes time to reach us, when we look at a galaxy far, far away, we see it as it was a long time ago. So looking at a bunch of galaxies different distances away is kind of a rough proxy for looking at the same galaxy at different times. The light from the stars in else. But once you know the universe is expanding, you might wonder if it's going to keep expanding somehow or eventually stop and crunch in on itself because of the attractive force of gravity.
So you guys will have answers to those questions and find out all about universe expansion. Again, how do we know the universe is accelerating? What we just talked about. Let's get all the details. Go ahead, watch all that on your own. If I showed all this on this video, it would take up too much time on the video, and YouTube would probably get mad at the video and say, oh, you can't use all the videos in your videos. I totally get that. Okay, I can only show like 10 seconds for each one. All right, so let's go and do our last practice question of the day before we talk about dark matter and dark energy a little bit. We've got how were we able to tell that the present-day cosmic background radiation derives from the Big Bang? A, wavelengths in the form of microwaves. B, the universe expansion discovery. C, temperature of negative 270 degrees Celsius. Or D, aging the universe at 14 billion years old. The correct answer is going to be C, the temperature directly links to the Big Bang radiation, right? So the Big Bang's radiation is very similar to those current radiation waves temperature today. Okay. I'll go ahead on page 8, our only video analysis question of the day. What is dark matter and what is dark energy? I've got a really great infographic video to show you guys, but go ahead and write this down on page 8. What is dark matter and dark energy? Let's go ahead and check it out. And this should be, I'm just going to say this will be the last video of the day. Sorry, guys. Okay. Let's go and just show a little bit of this. Pretty cool stuff.
Is really only a tiny fraction of reality. But it gets worse. We really have no clue what dark matter and energy are or how they work. We are pretty sure they exist, though. So, what do we know? Dark matter is the stuff that makes it possible for galaxies to exist. When we calculated why the universe is structured the way it is, it quickly became...
Okay. I'm going to pause there just to prevent YouTube from getting on me about it. But guys, really awesome stuff. Amazing is what I would show if we were in class, obviously. Amazing graphics, amazing statistics and details, all of which this video will, in 6 minutes, greatly help you understand and introduce to you. Okay, and this answers our video question as well. But just to get to it in today's lesson, why not? We'll get a little ahead here. I think I'm doing pretty good on time. I'm learning how to go at a better pace. All right, a faster pace maybe. You guys like that? Okay. Whoa, I am way off from where I was supposed to be. Oh, it started from the beginning. Oops. Mr. Campbell's bad here. Okay. That was Mr. Campbell's fault. All right, so let me go ahead and find where we left off. Give me 1 second, guys. Sure, you guys are used to when I do this sometimes in class. Okay. Where'd we go? What is dark matter and what is dark energy? Super important. Well, dark matter is an undetected form of mass that emits little. Oh, by the way, guys, this is going to go to page 9. I'm going to mark this just because I just want you guys to see that in the video itself as well. But this is going to be page 9, guys. Title is Dark Matter and Dark Energy. Dark matter and energy, what's the difference? Well, dark matter is an undetected form of mass that emits little or no photons. Again, photons, if you recall, are light particles, but we know it must exist because we observe the effects of its gravity. So there's something there. Think of space like a large ocean, and there's stuff floating around, stuff holding things. There's stuff sitting there that we can't see or touch, but that is still holding up planets, holding up galaxies. We're going to consider that, we call that dark matter. And then dark energy, but we know, and as you say here, but we know it exists because we observe the effects of gravity. Now, what's the difference with that from energy? Well, energy is an unknown form of energy that is causing the universe to expand fast over time. So again, there's energy out there causing this expansion, that force. So there's stuff, and then there's a force. The stuff sitting kind of like an ocean in space, matter. The force pushing that stuff outward, we call that the energy, right? The energy. Again, this is page 9. Last thing of the day, guys, what is the universe made of? Okay, normal matter, which includes all the stars, the planets, the asteroids, the moons. Okay, normal matter is only 4.4. You can make sure to write all this down on page 9, guys. Super important. Could be on our notebook checks, and you're going to need it for our quiz coming up. Normal matter, 4.4%. So very little of most of space is just what the darkness. It's the dark matter and dark energy, right? So the normal matter inside stars, right, all the elements there is 0.6, and the normal matter outside the stars, which is all the planets, all the asteroids, all the debris, all the gases, that's 3.8%. So little space is actually the stuff we know a lot about, which is the planets and all the materials. But the majority of it is dark energy, which is 71%, and dark matter making up the rest at 25%. That concludes our lesson for today, guys. Again, do not forget, we've got our vocab that is due Sunday. We've got the unit quiz on Friday. Make sure you're up to date with your work. I'm not gonna try to overwhelm you guys too much. I think we're gonna have one more notebook check, 1 or 2 more. I'm gonna lean more towards 1. But yeah, keep up with the work, guys. If you got questions, let me know. I'm gonna get grades updated fully as soon as possible, and we'll keep up going at staying on track with our work, and I will give you 2 more lessons this week. We'll post tomorrow as well. Take care, Mr. Campbell. I'm going to go ahead and sign out.